To find the rational zeros of this polynomial, we're going to use our rational zeros theorem. We take the factors of the constant term. So the factors of 3 are positive or negative 1 and positive or negative 3. Those are the only factors of 3. And we divide by the factors of the leading coefficient, which is 2. The factors of 2 are positive or negative 1 and positive or negative 2. So to do each of these, we want to look at each way to divide these. So we have positive or negative 1 over 1, which is 1. Okay. Positive or negative 1 over 2. Positive or negative 3 over 1, which is just 3. And a positive or negative 3 over 2. So those are our possible zeros for this polynomial here. So we're going to start testing. Let's start with 1 because small numbers are nice and easy to work with. And we list out our coefficients. And we work through our synthetic division. Bring the 2 down. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 8 plus 5 is negative 3. And negative 3 times 1 is negative 3. And 3 plus negative 3 is 0. And we got a 0 here, which means that 1 is a 0 of this function. So that means that x minus 1 is a factor. And what's left has these as our coefficients. So we've got a 2x squared plus 5x minus 3. Now at this point, we could continue testing numbers with this, but we have a quadratic here. So we might as well just factor that quadratic. Okay? And I think we're fairly comfortable factoring quadratics at this stage, so I'm not going to worry about all the details of that. We've got plus 3 here and a minus 1 here. Okay. And so that's our completely factored form. And so to get our zeros, well, we have x equals 1. And then for this, if we set that equal to 0, we get x equals 1/2. And if we set this last one equal to 0, we get x equals negative 3. And you'll notice, of course, that all of these are in that list that we generated from our rational zeros test, or rational zeros theorem. So we would have found those, but factoring actually kind of speeds the process up for us a bit, because going through and testing all of them, well, that's pretty tedious. So those are all of our rational zeros for this polynomial.